Hello, this video is to serve as a sort of introduction to ME104, which is a class given here at the University of Rochester. This class is a little bit different from the other mechanical engineering classes. It's not really mandatory, but it's a good head start. So a lot of the information here is kind of hard to find resources for it online, as a lot of it, the resources online relate to statics, which is a different class. But in this course, we used what is known as the equilibrium condition, which is what I'm going to be going over today, and how to create a free body diagram and how to create, how to use the summation of forces. Some other institutions might benefit from this class, or some other people, but generally this is meant for people who are taking ME104 engineering bridges. So let's start off with a box. So we have this box, and we can assume that there's a force here and there's a force here. Forces are denoted by arrows, and this arrow has a 50 kilonewton force behind it. And what is this arrow? What is this force? So the equilibrium condition basically just means that everything is at equilibrium, meaning that all the forces attached or like related to this add up to zero. So this means that it would be motionless. So for example, if we take something really small, let's say this little these like color crayons I got at the Museum of Rochester. If I were to pull on this one side, right? Let's say I pull on this side. If I pull too heavy, it'll move it, right? If I pull too much on this side, it'll move it as well. But if I move equally in both directions, it'll be motionless. It'll be equilibrium, because all the forces add up to zero. This force is equal to this force, which adds up, well, when subtracted, equal up to zero. Same can be said when they go. It's at equilibrium because there's all the forces connected to this are zero. So let's go back to the box and let's relate it. So we kind of can tell kind of intuitively, if this is not moving, this also must be 50 kilonewtons. But let's do it the way the mechanical engineers always do it, super overcomplicatedly. So we're gonna draw. We're gonna make this we're gonna make this box smaller. We're gonna make it a dot on a very small line. And there's a force here. And there's a force here. We know this force is 50 kilonewtons. And we don't know this force. We want to give this force a name since we're dealing with this. So we're going to call this F1. The name of the force does not really matter. For our intents and purposes, F1 is helpful because it's just a force, and this is the first force. Later on, you're going to be dealing with a lot of forces at this dot. So just getting into the habit of F1 or labeling it in order or in any kind of order helps, rather than labeling as force Henry or David or super awesome cool voice. So again, this dot represents this box. So this dot is also at equilibrium. Now we're going to draw what's called a coordinate system. X. So basically what this means is that forces moving in this direction towards the right are positive. We can call them positive forces. And forces moving opposite of that are negative. Well, what's a negative force? Well, we can't really have a negative force. That doesn't really exist, right? So basically all this means is the magnitude or the direction. This is going to the right, so we're calling it a positive, and this is a negative, so it's going to the left. Okay, since it's moving to the left, this is a negative force because it's going against the
coordinate system.
So now that we know that, we can kind of add up these forces, right? 50 plus F1, or minus F1, because this is going against the coordinate system. So how do we write that? It's gonna look scary, but it's not, I promise. Okay, what did I write? The summation, which means the addition of all the following, of the forces in the x direction. So the addition of all the forces in the x direction add up to zero, which is correct. That's equilibrium condition. This is what equilibrium means. However, we have our forces, so we can also set this equal to 50 kilonewtons. This is good because it's positive, right? Minus F1 because it's going against the the coordinate system. And now we can kind of just do basic algebra to solve for F1 equals 50, and there you have it. Of course, make sure to write your units. And that is a brief introduction to the equilibrium condition, free body diagrams, and coordinate system. This is a free body diagram, this is a coordinate system, this is the summation of forces. Hope this helps.